Hey guys, we're still on lesson 10.2. We're on task 3. We're going to write a system of linear inequalities. Alright, so it says use the graph to write the system of linear inequalities and identify the solution region. Alright, so I'm going to look at these lines and try to graph the lines first. So I'm going to say y. Let's look at the one on the bottom first. It has a y-intercept of 4. And I'm just using y equals mx plus b. Okay, so now I need to find my slope. My b is my y-intercept. And if I look at this equation, I can see that it starts at -1 and I go up 1, 2, 3, 4 over 1. So I'm going to have a slope of 4. And I can tell that it is shaded above, it looks like it's shaded above this line. So it would be greater than, and because it's a solid line, it's going to be greater than or equal to. All right, now we're going to do the same thing for the other one. So we have a y-intercept of 5. And I can look and see what the slope is. So if I start down here, it looks like it goes up 1 over 1, up 1 over 1. So it has a slope of 1x. And you can put the 1 or you don't have to. If you just put x, it's assumed to be a 1. But it looks like right here, this is a solid line and it's shaded below. So less than or equal to. So our system would be everything above this line and everything below this line. So basically this dark area here in the middle. All right, so that's what you have to do to write a system of inequalities. Just look at each line individually and decide if it's dotted or solid, and look to see if it's shaded above or below so that you can figure out your inequalities. All right, so let's see what questions we can answer from this. All right, it says, what is the slope of the line that has a y-intercept of 4? So the slope of that one was 4. All right, what is the slope of the line that has a y-intercept of 5? The slope of that one was 1. And it says first write the equation for each boundary line in slope-intercept form. Okay, I've already done that. So we got 4x plus 4 and x plus 5. And then they just included the inequalities. Okay, so it has, how can you justify that the inequality symbol is greater than or equal to for the first inequality? Okay. We know that because it was shaded above that line. So it was a solid line and it was shaded above the line. How can you justify that the inequality symbol is less than or equal to for the second inequality? It was solid and below. So either one where it says dash, we know for sure it can't be that one. So we're just checking the first and the third one. All right, you can verify the solution region by checking points for each region algebraically. A point must satisfy both inequalities upon substitution to be a part of the solution of the system. Oh, good. They've already plugged in the points for us. So we've got true, false. If we have at least one false, it means it's false. This one's true, true, true. False, 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 true. So the only one that works is -3, 0. If we go back up here and look, -3, 0 is right here, and it's in the dark region. That's in that double shaded region, so that is the solution. All right, so it says the solution region is the darker part of the graph, which represents the overlap of the graphs of the individual inequalities. The solution region includes the solid rays along the boundaries. Since these were both greater than or equal to and less than or equal to, that's why it includes both boundaries as well. All right, that is all for task 3. If you have any questions, let me know. All right, guys, lesson 10.2, task 4. Model with systems of linear inequalities. Jessica goes to a garden center to buy potted plants for her garden. Her favorite are pansies and mumps. She wanted to spend no more than $30, and she wants to buy at least 8 potted plants. Write a system and create a graph to model all the combinations of pansies and mums she can buy. All right, she wants to spend no more than $30. That means 30 is her max. And she wants to buy at least 8 plants. All right, so this shows us that pansies cost $5 and mums cost $2. Write a system, let X represent the number of pansies and Y the number of mums. All right, so we've got X plus Y greater than or equal to 8 because she wants at least 8 plants. And then we've got $5 times the number of pansies plus $2 times the number of mums has to be less than or equal to $30 because she's going to spend at most $30. All right, so it says, what does the second inequality represent? Jessica wants to spend less than 30. Well, less than or equal to. Jessica wants to spend at least, that means 30 or more, so no. Jessica wants to spend at most $30. So at most means less than or equal to $30. All right, it says, what do 5x and 2y in the inequality represent? All right, $5 times the number of pansies and then $2 times the number of mums is less than or equal to the $30. All right, so it says graph the system. They've already graphed it for us. So if you look, they have just taken the X and Y intercepts and plugged those in. That's an easy way to graph when it's in standard form. And then they have shaded above this line. All right, these have the 2 y-intercepts of 8. And then they've shaded below this line here. All right, so that means, again, I like to have my arrows here, shaded above this line and below this line. So you can see everything in the dark shaded area there is part of the solution. All right, it says, what combination of pansies and mums does the point 210 represent? All right, so 210, here's 2. 210 is a point right here on this line. So since it's a solid line, the boundary line is included in the solution. So this represents 2 pansies and 10 mums. Okay, 2 pansies and 10 mums. And yes, it works because it is a solid line. If it were a dashed line, it would not work. All right, what combination of potted plants and mums does the point 4-8 represent? All right, so here's 4 and 8 is right here. That's outside the shaded region, so that does not meet what it has to. So 4 pansies and 8 mums does not work for this situation. All right, what combination of pansies and mums are solutions to the system? Are there points in the solution that are not reasonable for a real world? And I want to look at this because that is true. When you're buying plants, this whole shaded region is the solution to that system, but you can't buy a half or a third of a plant. So again, only the whole number or the real number, I should say yes, whole number, because 0 would work. So whole number, all the whole numbers ordered pairs would work for this situation. If you have any questions about task 4, please let me know.